Hi, Algebra 1 students. These notes are on factoring using a difference of two squares, and also when you have the form x squared plus bx plus c. And this covers lessons 1 and 2 in Module 4 in your Eureka workbook. So to start, I just want to do a quick vocabulary review for you because we talked about polynomials at the beginning of the year in Module 1. And you do have notes, at least people in Ms. Penn's class have notes on Intro to Polynomials, which goes over some of this. I just wanted to refresh your memory. So underneath polynomials, there's monomials, binomials, and trinomials. And that is about the number of terms, that it has. So a monomial has one term, a binomial has two terms, and then a trinomial has three terms. And that's variables or numbers separated by addition and subtraction signs. Okay, so then I'm going to quickly write just a sample polynomial. Okay, some other vocabulary words here would be, we have the degree of the polynomial is always your highest exponent. So this would be a degree 2 polynomial, and remember, degree 2 polynomials are also called quadratic polynomials, or in this case, there's three terms, 1, 2, 3. So this would be a quadratic trinomial. A couple more vocabulary words. If you just have a term that's a number by itself without a variable, we call that a constant. A number being multiplied to a variable is a coefficient. And just to kind of help you remember, degree 2 is called quadratic. There's other names for other higher degrees, but this is the one we're focusing on most right now. Okay, so now that we get some vocabulary out of the way, because those are some words I'm going to be using during these notes, let's get into what is the big idea of what we're talking about here. So we're talking about a new process, a relatively new process called factoring, and it relates to multiplying. So we're going to kind of make a little flow chart where on one side we have standard form, and on the other side we have factored form of a polynomial. And then we're going to kind of draw a loop going from one to the other. So to go from factored to standard, this is what we have been doing. I'm going to just give you guys a quick example. That's like saying, okay, two binomials being multiplied. This would be a factored form because two factors are being multiplied. So you have two factors, x plus 3, x minus 2 being multiplied. So to get it into standard form, we call this process expanding, but it's also multiplying, right? So we know how to do that by either using distributive property or which is FOIL, or by using the box, right? So if we multiply here, we do x times x, x squared, x times negative 2, negative 2x, 3 times x, and 3 times negative 2. And then I can combine my middle terms, so what I get here would be my standard form, which is x squared plus x minus 6, right? So what we had been doing previously is moving from factored to standard form by multiplying, okay? Now what we're going to start to do is go from standard form into factored form by factoring, okay? So it's kind of like the opposite of multiplying. Now, before we get into some strategies for factoring, I wanted to kind of list out a couple of patterns that we notice when we're expanding or multiplying. The first pattern is something called a difference of two squares, and this was in lesson 1. And the idea here is if we multiply a plus b times a minus b, where you have like the same first two terms and second two terms in a binomial, but then one is plus, one is minus. something interesting happens here. So if we set up the box, we saw a times a squared, a times negative b, negative ab, a times b is ab, and negative b times b is negative b squared. So what happens here is the negative ab, when we go to combine the negative ab plus ab, they cancel and just equals 0, right? So then what we end up with is just the first term, a squared, and plus the second term, which is a negative b squared. And we call this the difference of two squares because a is something squared, b is something squared, and it's a difference, right? By difference, I mean subtraction. Okay, so this is one pattern that in the moment we're going to think about factoring. So we're going to start with the a squared minus b squared and then think about what are the a plus b and a minus b. The next pattern that we saw is when you're squaring a binomial. And we have two different examples. One is where the two terms are being added, and then the other is the two terms are being subtracted, and you get a slightly different pattern. So we can just kind of like kill two birds with one stone and set up both of them. And just quickly, I get a squared, ab, b squared. So when I go to combine, ab plus ab is 2ab, right? It's two of the same term. So I end up getting a squared plus 2ab plus b squared. And this is called a perfect square trinomial. Because we're squaring a binomial to get a trinomial, okay? So then in the second example with squaring binomials, we get a minus b now. So we still get a squared here, we still get b squared here, but now I have negative ab along the diagonals. So when I go to combine, I'm going to get a negative 2ab. So I get a squared minus 2ab plus b squared. So both of these are called perfect square trinomials. So if you can notice that you have some b values squared here, and then this looks like twice that, then you might be able to establish the pattern for factoring. This might help you factor, okay? So now that we kind of have those patterns formalized, we're going to take a look at factoring a difference of two squares, okay? So the key in this process is going to be identifying your a and your b, or what is being squared. So the idea is if you can identify what's squared in your binomial, then you can always factor it into the first thing plus the second thing times the first thing minus the second thing. So in this first example, I'm trying to think about what squared gives me both of the terms here. So like the first thing squared would be a, the second thing squared would be b. And so this, I have an x squared as my first term. So what's being squared to give me x squared? Well, just an x squared would be x squared. And then what squared gives me 49? 7 squared gives me 49. When I think about the second square, I'm ignoring the negative sign, okay? So now I can then easily factor if a is x and b is 7, I'm plugging in a and b into this formula. So I should get x plus 7 times x minus 7. And that would be the factored form of x squared minus 49. So this would be equivalent, okay? Now let's look at example 2. So again, you're trying to think what squared gives you each term. And that should tell us a and b. Okay, well, here, for 64, that's easy. 8 squared is 64. But I'm having this hard time with this 5 out front, because I can't think of a whole number that when I square it, I would get 5. So if there's nothing you can think of, then maybe this isn't a difference of two squares, right? So not a perfect square, which would be like the 5. So this, I can't do anything. All right, so if it's not both things being a perfect square, then I can't apply this method. I don't really know what else I can do here, okay? In the next example, example 3, similarly, so we can actually think of things that will square to give us those numbers or those terms, right? Because x squared gives me x squared and 6 squared gives me 36. But we run into a separate problem here, which is that this is not a difference of two squares. This is a sum of two squares because it is a sum. We have a plus sign right there. So if we don't have a minus sign, even if you have two perfect squares, we can't do this method. Okay, so those are kind of like two non-examples. Now, I kind of skipped over this remember box, but I want to come back to it now because sometimes what you'll have to do is before you think about the difference of two squares, you may need to factor out a GCF first. Okay, so what I'm going to write here is that first, try to factor out a GCF if possible. Now, like in the examples we've already done, there was no GCF between the terms. But in example 4, we are going to get to a GCF problem. So we are going to need that kind of reminder. So taking a look at example 4, 32x to the third minus 2x. There is a GCF here that I could take out. So this is where I am going to use this thinking about if there is a GCF, you should take it out. So when I look at 32 and 2, they both have a 2 in common, and then x cubed and x have an x in common. So that means I can take out a 2x, and then I need to write what's left over. So if I take out 2 from 32, I get 16. And if I take out an x from x to the third, I get x squared. And then in my second term, I took out an entire 2x. So the minus sign is still inside the parentheses, and I'm going to put a placeholder of a 1. So now, within the 16x squared minus 1, I'm wondering if that is a difference of two squares. So again, I'm going back to my difference of two squares process where I think, is this something squared minus something else squared? And that would help me find A and my B. So to get 16x squared, to get what squared is 16 would be 4, but then I also need what squared is x. So that would be x. So 4x quantity squared gives me 16x squared. And then in my second term, what squared is 1? Well, 1 squared is 1. So this is a difference of two squares, and then I can factor this. So I'm going to keep my GCF out front. I'll still have that monomial there. And in parentheses, I'm going to do a plus b and then a minus b. So it'll be 4x plus 1 and 4x minus 1. And this would be my complete factored form. So now I want you guys to try A and you try B before moving on to the next page of the notes. So moving on to the second page of the notes, this is on factoring when you have the form x squared plus bx plus c. And in lesson 2 of your workbook, that's what was going over this, where we were looking for patterns when we were multiplying binomials to see what's the relationship between the multiplication of two binomials and then a trinomial that you get as a result. And now we're going to try to do that process in reverse. And the way that I set things up is by what I'm calling the X method, where if you have a trinomial x squared plus bx plus c, and you're trying to figure out what the two factors will be, well, as we talked about in class, you're always going to have an x and an x if it multiplies to be x squared. And then we have plus some number, and I'm going to call those numbers m and n. Then we saw a relationship. We saw that those two numbers would multiply to give us our b value, would multiply to give us c, right? So it multiplies to c, and then we also saw that m plus n, whatever those two numbers there, they would add to give you your b value. And I kind of use this to kind of set up our puzzle. So we're trying to figure out what are the two numbers, that would be like m and n in this notation, that will both multiply to bc and add to bb. And nor if we can fill this x in, then we know how to factor, how to write those two binomials. Okay, so let's look at some examples. The first example, we have x squared plus 13x plus 30. So it's helpful to say what is what is your B and your C, and it's important that you keep the sign in front of the number. So B here would be the positive 13, and then C is positive 30. That means we need numbers that are going to multiply to be C, to be 30, and add to be 13. Okay? Now, I can actually think of it right away, what those two numbers would be, but if you can't, you can be systematic and kind of run through. 1 times what is 30? 30. 2 times what is 30? 15. 3 times what is 30? 10. 4 times what? Well, 4 doesn't go into 30. What about 5? 5 times 6. 7 doesn't go into 30. 8 doesn't go into 30. 9 doesn't go into 30. I think I'm done. I already got 10. So then I'm looking between all of this list of factors, which ones will also add to give me 13? Well, 1 plus 30, that's not 13. 2 plus 15 is 17. 3 plus 10, that's what gives me 13. So that helps me to identify what those two factors are. Now, when I go to write my factored form, I know it's always going to be x plus something. And then I now know what those numbers will be are 3 and 10. And you can always check by multiplying back through. If I do x times x, I get x squared. 3 times x, 3x. X times 10, 10x. Those will combine to give me my 13x. And then 3 times 10 is 30. So that checks out. Let's look at the next example. So once again, I'm going to start by identifying my B and my C. It's just going to make sure that I get the sign in front of the number, because here that 11 is negative, and I don't want to forget the negative because it will definitely change your answer. So then we need what multiplies to be 24 and adds to be negative 11. So as I'm running through my options, well, I'm going to just start by listing the positive factors of 24. So that's 1 times 24, 2 times 12, 3 times 8, 4 times 6. I think that's all there is. So now the thing is, though, if it multiplies to be positive but adds to be negative, that means both of the two numbers would have to be negative in order to add to be something negative. So I'm actually going to consider all of my factors as negative and then think which will add to be negative 11. Well, negative 1 plus negative 24, that's out. 2 and 12 is 14, that's out. Negative 3 plus negative 8, that's the one that's going to give me my answer, because negative 3 plus negative 8 is negative 11. So I now know that my two numbers are negative 3, negative 8, and then I can factor x minus 3, x minus 8. So the signs really matter here, because that's what gives us those subtraction signs here, and that's what gives us the correct factorization. And again, you can always check it by multiplying back through and seeing if you get the original trinomial. Okay, taking a look at number 7, the first thing I notice is that A is not 1 here, A is 2. So I'd like to see, is there a GCF? And actually there is, because if A isn't 1, I'd hope there's a GCF, because that makes my life easier. So then if I take out the GCF first, I'm just going to write us a little note, GCF first. Our GCF here between 2x squared, negative 4x, and 70 would be just a 2. So I take the 2 out, and then what's left over is x squared minus 2x minus 35. And now I'm kind of zooming in on what's inside of the parentheses, and that's what I'm going to use to set up the x method. So I need something that will multiply to be negative 35 and also add to be negative 2. So I'm going to list out my factors of 35. So that would be 1 in 35, 2 doesn't go into 35, 3 doesn't go in, 4 doesn't go in, 5 goes in 7 times. And that's all there is, right? Now I know that these multiplications will give me positive 35, but I want negative, which means that one of my two factors would have to be negative, right? So we kind of have to have two different sets of options. We can do negative 1 and positive 35, or we could do positive 1 and negative 35, and then we could do negative 5 and positive 7, or positive 5 and negative 7. right? So then I'm going through and I'm wondering which of these pairs will add to be -2. Well, not the ones with 35 and 1. This is going to be positive 34. This is going to be negative 34. -5 plus 7, that's 2. But I want it to be -2. So I'm hoping that probably means that this is going to be my right answer. Because if I do -7 plus 5, that is -2. So now I know 5 and -7 are the two numbers that will work. So that means that my completely factored form has that GCF of 2 out front, and then x plus 5, because the 5 was positive, x minus 7, because the 7 was negative. Okay, I just have one more example for you guys. So here I'm doing my B value is -8 and my C value is 16. You don't always have to write this out. I forgot to write it out over here, but it is a good habit, especially at the beginning, so you don't make any small mistakes. So we need something to multiply to 16 and add to be -8. What I noticed right away is that 16 is a perfect square. This is 4 squared. So that kind of clues me in that this might be a perfect square trinomial, like that pattern on the front. And especially because 8 is 4 times 2, right? So that was part of the pattern, that the middle term was 2ab. So I'm thinking then that it's going to be 4 and 4 that work here. So 4 times 4 is 16, but wait, I have to get to -8. So I'd have to do -4 times -4, because -4 times -4 is still positive. Negative times negative is positive, but they will add to give me my -8. So then the two factors I want to fill in, the two numbers I want to fill in here will be a -4 twice. So when I go to write my answer, I can either I can write x minus 4 times x minus 4. I could write the same thing twice, or I could just write the binomial once and then say squared, right? These two are equivalent. Okay, so do the best that you can on these U-tries. This first one, C, there is a GCF to take out before you do the X method, so make sure you do that first. And then you also have D down here.